I was looking at a map of the internet the other day, not a logical map, but a physical one, and it's just staggering. I think we all have this idea of the cloud as this, this fluffy abstract thing where our photos just float. But when you actually peel back the layers, it's surprisingly heavy. It's physical.
It really is. It's heavy cables snaking under the ocean. It's these massive windowless buildings just humming with fans and electricity. It is an incredibly complex web of logic holding it all together. It's not magic at all. It's engineering.
Exactly. And that disconnect between the magic button on a screen and the massive industrial machine that executes that click, that's what we're unpacking today. We're diving into some source material titled AWS Practitioner 301, Deploying and Operating in the Cloud.
Which I'll admit sounds a little dry on the surface, deploying and operating. But this is actually the good stuff. This is pretty much the manual for how a huge chunk of the internet actually functions.
Right. And for anyone listening who hears 301 and immediately thinks textbook, just stick with us. Because our mission today is really to decode that alphabet soup. We're going to tackle IaaS, PaaS, SaaS, IaaC, all those acronyms that usually make people's eyes glaze over, and figure out how you actually build something that doesn't fall over when everyone tries to use it at once.
And whether you're prepping for a certification or you just want to understand what your IT department is actually arguing about in meetings, this is the operational backbone. We're trying to bridge that gap between just clicking buttons and actually architecting a resilient system.
So let's get into it. The source material kicks off with what it calls deployment models. And reading through it, it feels like a hierarchy of control versus convenience.
That is the perfect way to frame it. It's a sliding scale. On one end, you've got total control, but you have to do all the work. On the other end, you do almost no work, but you get very little control.
And the do all the work end of that spectrum is IA, right?
Yeah.
Infrastructure as a service.
Correct. Think of IaaS as the raw building blocks. We're talking virtual computers, networking, storage space. It gives you maximum flexibility. If you want to build some weird custom server that runs an OS from 1995 for some legacy reason, IaaS is where you do it.
But there's a catch. The source mentions a big trade-off here with responsibility. It's not just, can I do it? It's more like, am I on the hook if it breaks?
A huge trade-off. It's the shared responsibility model. With IA, AWS handles the physical stuff, the security of the cloud. They make sure the data center has power, that the guards are at the gate.
That the hard drives aren't on fire.
Exactly. But you, the customer, you're responsible for security in the cloud.
So if I spin up a virtual server, an EC2 instance, AWS makes sure it turns on. But if I forget to install a firewall or leave the password as admin,
that's entirely on you. You handle the operating system, the patching, the network traffic rules, the encryption, the authentication. It's like renting an unfurnished apartment. The landlord fixes a leaky roof, but if you leave your front door wide open and someone walks out with your TV, that's your problem. You have to buy your own locks.
That's a very clear way to put it.
Well,
okay, so let's slide down that scale to something a little less stressful. Pays platform as a service. The source material actually uses the word relax here, which I found kind of funny.
it is rare to see the word relax in IT documentation.
Yeah.
But yeah, Pays Plus removes your need to manage all that underlying infrastructure. No more worrying about patching the OS or maintaining the hardware. You're basically saying to AWS, here's my code, here's my data, you handle the environment it all runs in.
And I see this used for a lot of specific heavy lifting functions. The notes mentioned database management, containers, AI, that kind of thing.
Exactly. I mean, if you need a database, do you really want to spend your week installing SQL updates and configuring backups? Or do you just want a database that works? That's PS. It's perfect for developers who just want to ship an app without having to become a full-time system administrator.
But again, the trade-off is control. You're playing by the platform's rules.
Right. If the platform only supports Python 3.8 and your app desperately needs Python 2.7 for some old library, well, you might be out of luck. You can't just get in there and change the core settings.
And then we hit the far end of the spectrum. SaaS, software as a service. This is the hotel experience.
It's a comprehensive solution, yeah. This is where the provider manages absolutely everything. You're not patching, you're not coding, you are just logging in and using it.
Like web-based email.
Right.
Or a CRM system.
Precisely. Or payroll services, business analytics tools. And what's fascinating is this kind of nesting doll effect. A lot of SaaS providers are building their software using IS or PS from someone like AWS.
So the payroll software I use might be running on an AWS server, which is ISS, but to me, it's just a website I log into.
Exactly. For the end user, SaaS is usually the goal. But for the builders listening, you're usually operating in that IS or PaaS layer to create that SaaS experience for someone else.
Okay, so we've picked our model. We know what we want to build. Now, how do we actually tell the machine to do it? The source gets into access methods, and it seems like there's a manual way and a pro way.
There's always a pro way. The manual way is the management console. That's the website. It's secure. You log in and you click through menus. It's great for learning or for doing something just once.
But if I'm managing 1,000 servers, or I need to spin up a test environment every single morning, I'm probably not clicking launch 1,000 times.
Yeah.
That just sounds like a recipe for mistakes.
Please don't do that. No, that's where programmatic access comes in. You've got Cloud Shell, which is a command line in your browser, but the real workhorse, the thing you see on the screens of all the serious cloud engineers, is the AWS CLI, the command line interface.
The matrix-looking screen with all the text?
Right. It's a unified tool for Linux, Mac, Windows, and the source highlights a very specific command that's like the entry point to all of this, AusConfigure.
I wanted to ask about that because the notes really flagged it as important. It sounds simple, but it's doing a critical security handshake, isn't it?
It is. When you run AusConfigure, it asks for 4 things: your access key ID and your secret access key, which are your username and password for the robots, basically. Then your default region and your output format.
Which is usually JSON.
Yep, JSON is the lingua franca here. Once you've done that, your laptop is authorized to command your entire cloud account. But, and this is a huge but, you have to protect those keys. If someone gets your secret access key, they are you. They can be mining Bitcoin on your credit card in seconds.
Note to self: do not commit keys to GitHub.
Never commit keys to GitHub. That is a rite of passage you do not want to go through.
Okay, but even typing commands can be slow if you have to do it over and over. This is where it gets really interesting for me. The concept of IaaC infrastructure as code. This feels like the biggest shift in IT in the last 20 years.
It's the holy grail of modern operations. It really is.
Break that down for me. Infrastructure as code sounds like a contradiction. Infrastructure as metal, code is just text.
It used to be metal. Now it's virtual. So instead of manually clicking or typing commands to launch a server, you write a script, a template, usually in JSON or YAML. You just say, I want one server, one storage bucket, one database, all connected like this. You then feed that file to a service like AWS Cloud Formation.
And CloudFormation just reads the script and builds it.
It provisions it exactly as you described. The source mentions that AWS calls this whole collection of resources a stack.
And the beauty of the stack is automation and repeatability. If I need the exact same setup in London and Tokyo, I just run the script twice.
Exactly. And think about updates. If you need to change a firewall rule on 50 servers, you don't log into 50 servers. You change one line of code in your template and tell CloudFormation to update the stack. It eliminates what we call configuration drift, where servers slowly become different over time.
The notes also distinguish between one-time operations and repeatable operations. I'm guessing IAC is the king of repeatable.
Absolutely. A one-time operation might be creating your first user role or archiving old data. You do it, you're done. But repeatable stuff, auto-scaling, patch schedules, deploying new app versions, that should all be code. If you're doing it manually more than once, you're probably doing it wrong.
Which brings us to the plumbing. We've built the servers, we've automated them. But a server that can't talk to anyone is just a warm rock. We need to talk connectivity.
The pipes.
Let's start with getting traffic in from the public internet. The source lists a few key acronyms here, IGW and ELB.
So IGW is the Internet Gateway. Think of it like the modem for your house. If you have a public part of your network that you want the world to see, traffic has to go through the IGW.
But we don't usually let people connect straight to a specific server, do we? That feels risky.
It's risky and it's brittle. Instead, we use an ELB, an elastic load balancer. The load balancer has the public address. It takes all the incoming traffic and distributes it to your servers behind the scenes. It's like a receptionist directing calls, so the CEO doesn't have to answer the main phone line.
Okay, now here's a scenario from the notes I found really practical. What if I have a private server, like a database? It shouldn't be on the internet, but it needs to download a security update, so it needs to get out, but nobody should be able to get in.
That's a classic networking problem, and the solution is the NAT gateway. NAT is network address translation. You put the NAT gateway in your public network, and the private database talks to it. The NAT gateway then talks to the internet on its behalf.
It's like sending a courier to pick up a package so you don't have to leave the secure building.
Perfect analogy. But, and this is a big warning, the source material flagged AWS charges more for these, so they're not super keen on you overusing them.
Ah, the hidden costs. Is it that expensive?
It can be. It catches a lot of people by surprise. You pay an hourly rate just for it to exist, and you pay for every gigabyte of data that goes through it. So if you're pushing terabytes of backups through a NAT gateway, your bill is going to be astronomical. It can be a financial bottleneck if you're not careful.
Good to know. Okay, what about connecting my actual office, my on-premise data center, to the cloud? The source lists two main ways: VPN and Direct Connect.
This is the classic convenience versus performance debate.
Let's start with the VPN, site-to-site VPN.
It's quick to set up. You have a virtual private gateway on the AWS side and a customer gateway, just a router or firewall on your side. It connects over the public internet, all encrypted.
And the notes mention a specific speed limit here, 1.25 gigabits per second.
Which is fine for a small office or basic backups. But since it's on the public internet, the performance can fluctuate. It's like driving on a public highway. Usually it's okay, but at 5 p.m., there's traffic and your data slows down. You can't control it.
So if I'm a big bank and I need to move petabytes of data reliably, the highway isn't good enough. I need a private train track.
Enter AWS Direct Connect. This is dedicated fiber. It physically bypasses the public internet. You're running a cable from your gear directly into the AWS backbone.
And the speeds are in a different league.
A huge difference. It starts at 10 gigabits, but you can go up to 100, even 400 gigabits per second. And because it's dedicated, the latency is flat, no jitter.
And secure, too. The notes mention MCSec.
Right. MSEC encrypts the data at the hardware level, literally at the layer of the cable itself. So for government or banking, this is often a hard requirement.
But obviously, digging a trench for fiber takes a lot longer than setting up a software VPN.
Months versus minutes, and a lot more expensive.
Okay, just to wrap up connectivity, there's this thing called the transit gateway. This solves a specific kind of architectural mess, doesn't it?
The spaghetti problem, yeah.
Yeah.
Imagine you have 50 different cloud networks and 10 different offices. If you try to connect every single one to every other one, you end up with hundreds of connections. It's totally unmanageable.
So transit gateway is the central hub.
Exactly, the hub and spoke model. Everyone connects once to the transit gateway, and it routes all the traffic. It simplifies complex networks massively.
Okay, we're moving fast, but I want to make sure we cover resilience. Because the cloud breaks, everything breaks eventually. How does AWS keep things running?
It is all about redundancy. The core unit of redundancy is the availability zone, or AZ.
What is an AZ, really? Because I think people confuse it with a region.
Physically, an AZ is one or more data centers in a specific location. They have their own power, cooling, networking, and crucially, they're physically separated from other AZs by a few miles enough that a flood at one won't hit the others, but close enough for super fast connections between them.
And the source is some services just use these automatically.
Yeah, S3 for storage and DynamoDB, the database, they automatically replicate your data across multiple AZs. You don't even have to think about it. If one data center goes down, your data is safe.
But for other things, like a standard database, you have to opt in.
Right. With Amazon RDS, you have to check the box for multi-AZ. But with Aurora, their cloud-native database, it's even more robust. It replicates across 3 AZs by default.
Now, zooming out, regions.
Mm-hmm.
A region is a collection of these AZs. So why would I want to use multiple regions? Why not just put everything in, say, Virginia and call it a day?
Well, Virginia is great, but there are 3 big reasons to go multi-region. First is compliance. Data sovereignty laws. If you have German customers, German law might say their data absolutely cannot leave German soil. So you have to use the Frankfurt region.
That's non-negotiable for a lot of businesses. What's number 2?
Performance. Latency. The speed of light is fast, but it's not infinite. If your user is in Tokyo and your server is in Virginia, every click has to travel halfway around the world and back. It's going to feel slow. You want the workload close to the user.
And the third?
Disaster recovery. On a global scale. If, heaven forbid, an entire region goes offline because of a massive hurricane or something, having a backup on another continent keeps you in business.
The source lists some tools for this, like Route 53 and Global Accelerator.
Route 53 is DNS. It's the phone book of the internet, but a really smart one. It can see where a user is coming from and direct them to the closest region. Global Accelerator is interesting. It uses AWS's own private network to route your traffic faster than the public internet. It's like taking the toll road to avoid all the local traffic.
Speaking of getting closer to users, we have to talk about the edge. This isn't the same as a region, right?
No, and that's a really important distinction. An edge location is not a massive data center for running servers. It's a smaller facility in a major metro area specifically for delivery.
So this is where CloudFront comes in.
Exactly. CloudFront is a content delivery network, a CDN. Let's say your big video file is hosted in London, but a user in New York wants to watch it. Instead of streaming it all the way from London, AWS caches a copy in a New York edge location.
So the user downloads it from a server that's practically down the street.
Much, much faster, and it reduces the load on your main server. The notes describe the flow as origin server, Taro regional cache edge location, DFS user.
And it's not just for files. The notes mention security too, WAF and Shield.
Yes. Because the edge is the first point of contact for traffic, it's the perfect place to filter out the bad guys. DDoS attacks, hackers, you stop them before they even get close to your actual servers. It's your perimeter defense.
It's impressive when you look at it all together. It's this massive layered ecosystem. So, to recap the journey we just took, we started by choosing our model. Do we want the control of IaaS or the convenience of SaaS?
We then figured out how to control it, using the CLI for power and infrastructure as code to automate the whole thing into a repeatable stack.
We laid the pipes internet gateways for public traffic, NAT gateways for private, while watching those costs, and direct connect for the really heavy lifting.
And finally, we distributed it. We used availability zones to survive a small outage, regions to survive a disaster or obey the law, and edge locations to make it lightning fast for every user.
It really just highlights that the cloud isn't one thing. It's a set of choices.
It is. And what really stands out to me is that while the tools are so powerful, the real complexity is in making those choices. You have to balance cost. Remember that NAT gateway warning against speed, like paying for direct connect against control.
It's not just put it in the cloud, it's how do you want to live in the cloud?
Exactly.
Before we sign off, I want to leave you with one last thought. We talked a lot about infrastructure as code today defining servers in JSON and YAML files. So, if we can define entire stacks in code, and we can automate the updates and patching is handled by PaaS, are we moving toward a future where operations as a career is purely a software development task? Is the person who used to plug in cables or click install update not just outdated, but completely obsolete?
That is a fascinating question. I mean, if the infrastructure is just another repository on GitHub, maybe the sysadmin really is evolving into just another specialized kind of developer.
Something to mull over while you configure your next stack. Thanks for listening to this deep dive into the operational backbone of the cloud.
See you in the next region.
Take care, everyone.